Hi, welcome to clickmeproject.com. This video will lead us to the demo of a probabilistic misbehavior detection scheme towards efficient trust establishment in delay-tolerant network. Malicious and selfish behaviors represent a serious threat against routing in delay or disruption tolerant network. Due to the unique network characteristics, designing a misbehavior detection scheme in DTN is regarded as a great challenge. We propose iTrust, a probabilistic misbehavior detection scheme for secure DTN routing towards efficient trust establishment. The basic idea of iTrust is introducing a periodically available trust authority to judge the node's behavior based on the collected routing evidences and probabilistically checking. We model iTrust as the inspection game and use game theoretical analysis to demonstrate that by setting an appropriate investigation probability, TA could ensure the security of DTN routing at a reduced cost. To further improve the efficiency of the proposed scheme, we correlate detection probability with a node's reputation, which allows a dynamic detection probability determined by the trust of the user. The extensive analysis and simulation results show that the proposed scheme substantiates the effectiveness and efficiency of the proposed scheme. First of all, the network creation is the first process. In network creation, we should create a nodes, that is the user defined nodes. These nodes are used for the data transmission. Then the individual user ID is provided to all the nodes in the network. Then there are three algorithms are available in the network for produce the key. From these three algorithms, the user can select any one of that and then use that algorithm for produce the key. These keys are assigned to each and every nodes in the network. Then the nodes in the network must deposit amount for joining the network. And then in iTrust, the evidence generation phase is very important, in that there are three evidences. They are delegation task evidence, forwarding history evidence, contact history evidence. These three evidences are generated by the sender, intermediate and the receiver. The sender will generate the delegation task evidence, the intermediate will generate the forwarding history evidence, and then the receiver will generate the contact history evidence. After these three evidences are created, the auditing phase will be executed. The trusted authority plays the vital role in the auditing phase. The trusted authority sends the investigation request to the sender, intermediate and the receivers. Then the sender sends the delegation task evidence to the trusted authority, and then the intermediate sends the forwarding history evidence to the trusted authority. The receiver sends the contact history evidence to the trusted authority. On the basis of these three evidences, the trusted authority find that the intermediate is a misbehavior or not. If the intermediate is misbehaved means, then the cost, that is deposit amount of the intermediate, is not refunded. If the intermediate is not misbehaved in the network means, then there is no problem for the deposit amount of the intermediate. Let us see the demo of a probabilistic misbehavior detection scheme towards efficient trust establishment in delay-tolerant network. Click anywhere in the place. Now the probabilistic misbehavior detection scheme is started. It is the network. Here we have to enter the number of nodes and then press the create button. Now the nodes are created and then the unique IDs are also generated automatically. Now there are 3 cipher algorithms are available. They are AES, DES, Blowfish. From that you can select any one of the algorithm and then press keys. Now the each and every nodes having the unique ID, keys, and then all the nodes in the network deposit amount is also present. Now the keys are distributed to the nodes in the network. Now press OK. Now the iTrust is started. Here you have to select the sender from the network and then the sender ID, key, and the deposit amount of the sender is displayed to you. Now select the receiver from the network. The receiver ID, receiver key, and the deposit amount also display. Now press the routing model. It is the starting phase in the routing model. In routing we have to calculate the distance between the sender and the other nodes in the network. From that distance find the nearest nodes in the network. Now press find nearest. Now set the flag value to 1 for the nodes which are nearest to the sender. The nodes that are distance from the sender is having the flag value as 0. Now press path cost. Here the nodes which are displayed is having the flag value as 1. In path value the cost for each path from source to the other nodes is calculated. From this path cost calculation the intermediate is selected based on the lowest cost. Press the routing and then you have to know what is the intermediate. Now the intermediate is 23 and then press cost. It shows the cost for the sender and the intermediate. Now press iTrust. In iTrust the sender will send the data so that the sender selects the data. Now the data is displayed here. Now press next. Here the user will generate the signature for the data that transfer. Now press generate. Now the signature is generated and then now press send. Now the signature and the data is sent to the intermediate. Now press accept. The data is accepted in the intermediate. Now the intermediate also create the signature for the data. Now press create. The intermediate generate the signature. Now press delegation. In this the signature of the intermediate is transferred to the sender. Now press delegation in the sender so that only the signature of the intermediate is received in the sender. And then if the delegation is started means then the timer, that is the stopwatch, is started, that is the delay time. Now press send. If the intermediate send the data to the receiver before the timestamp means then the receiver got the data and then the receiver got the signature of the intermediate. Now press create. The receiver generate the signature for the data that received, and then press delegates. It will send the signature of the receiver to the intermediate. Now press delegation. This is the signature of the receiver, and then the trusted authority is started automatically by the receiver. Now the trusted authority starts the auditing phase. In auditing phase, the investigation request is sent to the sender, intermediate, and the receiver. Now the sender send the signature of the sender and the intermediate is displayed, and then the sender send the delegation history, the intermediate send the forwarding history, the receiver send the contact history. Based on this, the trusted authority find that the intermediate is a trustworthy node. Now press OK. If the intermediate does not send the data to the receiver within the timestamp, means the send button is disabled, and then the trusted authority is started automatically. Now the trusted authority send the investigation request to all the sender, intermediate, and the receiver. Now the sender send the delegation history, the intermediate send the forwarding history, and then the receiver send the contact history, but the data are not available in the receiver. Then from that, the contact history and the forwarding history, the trusted authority find that the intermediate is acted as a selfish mode, and then he misbehaves in the network, so that the intermediate is punished, and then the deposit amount that paid by the intermediate is not refunded.